So right around 75 degrees room temperature, you should have right around 1,100 ohms resistance. And again, this is a PTC, or positive thermal coefficient. So as temperature goes up, so should my resistance. Okay, normally we talk about NTC, negative thermal. But in this case, on cooking, it's a positive thermal. As temperature goes up, so does my resistance. So it's a PTC. Make sure we got proper voltages. If you got a gas unit, make sure you got proper 110 voltage. If you got a electric range, make sure you got proper 240. Then we start getting into what is the customer cooking. If we've gone through all of our checks, everything looks like it's working properly, and we've done our temperature check, which I'm going to talk about coming up here in a minute, but that looks like it's doing what it's supposed to. Then we need to look at what the customer is actually cooking and how they're cooking it. Pans are going to give you entirely different results. For example, this is a bundt cake that was baked. My daughter baked in 2 different style pans. She had to double the recipe for a school project. And we had 2 different style bundt pans. One was a shinier metallic light color. One was a darker one. And the cakes came out very different. Notice that I have a much larger space on the sides than I do on the front or the back. That is going to alter the way my cookies bake on the front and the back, as well as the sides. Because again, I have more airflow here, so the ones on the sides are not going to be done as well, but the ones on the front and back are going to be a lot crispier. Then we also have to take into consideration that glass cooks different than metal. A high-walled casserole dish cooks differently than a shallow pan does. All of this matters. Now, since you brought it up, here's how we're going to, wrong one. Here's how we're going to cook, or how we're going to test this unit. This will take roughly about 45 minutes to an hour. If you're going to test the unit properly, it's going to take